This conference will now be recorded.
Okay, so good morning all and welcome back to the session that is Big Data Masters program. From the big data perspective, from our module perspective, we have gone through with the module one that is like big data basics and certain introduction uh, from the Hadoop side. And then we have started our second module that is distributed processing with Pyspark. So this is our second module, distributed processing with Pyspark, and for this particular module, we are having certain prerequisite like the installation, the environment setup we need to have. So Spark environment setup sub module it has been covered, and this PySpark is having base from Python. So certain sessions we have gone through from the Python perspective. We have uh, covered Python in our previous sessions. So today we are going to start distributed processing with PySpark. It will be a little bit theoretical session, and from the next session onwards, like we will be having major focus onto the practical, but like we need to first have the understanding what exactly PySpark is, and then we will be able to code for that particular distributed processing framework. So let me start the day and mention Apache Spark. Apache Spark. So Apache Spark, and the module name is distributed processing with PySpark. Okay, that is our second module. Now, once we are talking about Apache Spark or PySpark, or you can say Spark with Scala, like there are certain aspects that we need to learn, like why we need to go through with PySpark only, why like what are the betterments those are given by Scala, okay, what exactly is given by Spark. So those particular basic things we need to understand, and then we will be able to write down good code in Spark. So Spark basically. So what we are going to learn, what is Apache Spark? What is Apache Spark? So Spark, this is nothing but a general purpose in memory compute engine, in memory distributed compute engine. Okay, so why distributed? Because like monolithic machines were not able to handle huge amount of data. Then what we are doing over here, we are clubbing multiple machines in order to process the data, and that is known as distributed computing or distributed processing. So if I need to explain what is Apache Sparks, then I can explain it with the help of three words. That is general purpose. First one is general purpose, general purpose, then in memory, and third one is compute engine. So these are the three words with the help of what we will be able to explain what is Apache Spark, compute engine in memory, general purpose in memory compute engine. So I will start from the bottom and then move towards the up, you can say upside, in order to describe all of these three words. Compute engine. So first of all, first I'm going to pick compute engine. So what exactly is the meaning of compute engine. So if we are able to recall Hadoop, what was there in Hadoop? Inside the Hadoop, we were having three components. Hadoop was having three components. Number one, HDFS, then MapReduce, and then Resource Manager. Resource Manager. So these are the three components which are available inside the Hadoop ecosystem. Inside the Hadoop, you can say world, these are the three main components. With the help of that, Hadoop is able to function. Hadoop is able to work. And HDFS is nothing but the storage layer. Storage layer. This MapReduce is nothing but processing layer. Processing layer, and resource manager is nothing but uh, like managing over here yarn basically, and acting as a resource manager, or working as a resource manager to manage all resources in Hadoop ecosystem. Okay. So it is acting as it is working as a resource manager. The main purpose is to manage all the resources inside the cluster. So these are three main components inside the Hadoop ecosystem: HDFS, MapReduce, and resource manager. But if I am going to say that this Spark is going to replace Hadoop, if I say the Spark is going to replace Hadoop. So will it be able to replace Hadoop? This particular Spark will not be able to Hadoop, because that will be uh, unfair, you can say, comparison, because like SDFS, that is working, that is the storage layer inside the Hadoop ecosystem, and resource manager like managing all the resources in Hadoop ecosystem. But from the Spark perspective, Spark is not having its own storage and resource manager. It is dependent on to, you can say, like say Hadoop or Kubernetes, or it can have different storage, you can say medium or mesos or standalone. So it is having different, you can say, resource managers. It is going to like take different resource manager, and it is able to work, Spark is able to work with different, you can say, storages as well. But the main thing is that over here, like if I'm going to replace it with Spark, so it will be like I'm just going to change the compute engine over here, the processing layer. This is nothing but the compute engine. So at this moment, like what I can say, Spark is able to replace MapReduce. Okay, and MapReduce is nothing but the compute engine. So what we are able to see over here, compute engine. Spark is general purpose in memory compute engine. It is not able to replace Hadoop, but it can replace MapReduce inside the Hadoop ecosystem. And Spark is saying what? Spark is saying, boss, give me the storage of your choice. Give me the RM, resource manager of your choice, and I will be able to perform task in a better way. if we compare it with Hadoop. Okay, so what we are able to see over here, Spark is the compute engine. It is able to map reduce, and this is very famous combination in the market. If we are keeping HDFS as a storage layer, Yarn as a resource manager inside like distributed processing framework, once we are having compute engine as a Spark, so uh, we like most of the organizations are using this particular combination. This is most famous combination. So what we are able to see, Spark is not able to replace Hadoop, but it is able to replace MapReduce. That means it is nothing but a compute engine. We can club different storage layer, we can club different resource manager with it, and we will be able to work in a good way, in a better way. That is what Spark is saying. Okay, we can have S3 as well. Okay, we can have RDBMS as well as a storage layer. MS, we can have NoSQL database. Okay, so we can get the data from any of these particular unit. Azure Blob is there, say Azure Blob. Okay, we can have any unit over here that is capable of storing the data. So we can directly club it with Spark, and we will be able to perform the operations. Then from the resource manager perspective, friends, we are having different resource managers. Say Kubernetes there, we are having Mesos, we are having Spark standalone, and resource manager over here say Yana. So we can have different resource managers, we can have different storage layer, but this compute engine will remain same, and we will be able to work in a better way if we compare with the rest of the processing engines or compute engines. So that is what Spark is saying. And what we are able to see over here, like how we can say Spark is a compute engine. Spark is like able to patch patch up with any storage layer. It is able to patch up with any resource manager, and then processing will be done on to top of the data that you are having. So what I am going to explain over here, like what is Apache Spark and what I have mentioned, Apache Spark is general purpose in memory compute engine, and we are able to understand the definition of compute engine. Now in memory, the second word that is nothing but in memory. Why, like we are saying, say Spark is in memory compute engine. So previously, what was happening in the world of Hadoop? Say we are having MapReduce one. Say we are having different jobs. So MapReduce one, we are having MR one, we are having MR two, we are having MR3, MapReduce three. We are talking about the Hadoop example. Okay, we are having different MapReduce jobs, MR4 and MR5. Okay, MR5, MapReduce 5. And what is happening over here? We are having storage layer HDFS. Okay, so once this particular MapReduce job is done, then what it will do? Let me try to use Paint. So say we are having MR1, MR2, MR3, okay, and MR4. Okay. So in this particular way, say I'm having a different map reduce jobs and we are having HDFS layer. HDFS is nothing but the storage layer. Now, once like this MR, this map reduce need to work, then what it will do, it will take the input from this storage layer. Okay, it is going to take the input from HDFS, that is nothing but the storage layer. It will work on to the data that is given by HDFS. This is nothing but compute engine in the world of Hadoop. So from HDFS, from the storage layer, it is going to take the input, it is going to work, and then finally, after getting the output, it is going to store it inside the HDFS. In the same fashion, once this MapReduce2 need to work, it is going to take the input from the HDFS, take the data from the HDFS. It will work on to top of that particular data and then store the output onto the disk. Basically HDFS is nothing but disk. We know this is the disk processing system. And in the same fashion, like MapReduce 3 will take the data from HDFS, it will work on the data, and then finally after you can say processing that particular data, store the result onto the HDFS. That is nothing but disk. In the same fashion, this MapReduce 4 is going to like take the input, it will work on that data and store the outcome onto the HDFS. So if we are able to see over here, once we are having four machines, then we are having 1, 2, 3, 4, 5, 6, 7, 8. 8 disk sick operations are there. 8 disk sick operations are there. Once we are running with four you can say map reduce jobs, okay, or you can say once we are having four node and these four nodes are working on to top of that data, then there are 8 disk sick operations. And disk sick operations, that is you can say input and output of these are the input and output operations, and these are time consuming operations. Okay, if like my job is taking too much disk sick operation, that means that particular job will be having high latency and that job will not be performant. And same was happening in the world of Hadoop. Okay, so disk sick operations was more over there. So what has happened in the world of Spark, now in the world of Spark, it is like this. Say we are having say we are having say job one, like say V1. Okay, then V2, and then say V3 and say V4. These are nothing but say jobs basically. What uh, like we have used MapReduce over here. Over here we are using the variable V1. So what will happen in the same fashion, we are having HDFS over here. Okay, so in this particular case, once like this particular like these particular you can say variables or nodes are need to perform the you can say need to process that particular data, then only you can say this particular machine is going to take the input from disk. Okay, it is going to take the input from disk, it is going to process over here, pass it to V2, V3, V4. Okay, and then finally after you can say processing from the V4, the output is stored inside the HDFS. Okay, so what has happened at this moment? Like disk seek operations has been reduced to two. Like first one is this one, and second one is this one. Uh, Okay, so this is nothing but a particular, you can say, data is stored. This is in memory layer. Okay, in memory layer, all the operations will happen over here, and once the operation has happened, the outcome will be stored inside the HDFS. So only two SIG operations are there over here, like uh, 8 6 operation was there, but over here we are having only 2 operations, and that is because like this Spark is working as in-memory compute engine. In memory, like it is loading the data inside the memory, do the functionality over there, and then finally move the outcome onto the disk. So disk sick operation has been reduced over here if we compare it with Hadoop. So Hadoop was having high number of disk sick operations, and because of that, that is having latency related issues, or that is not so much performant in comparison of Spark. So that is the, you can say, definition of the second word, like this Spark is in-memory compute engine. Whatever the data we are passing to Spark, it is going to move it inside the memory, and then inside memory the operations will happen and we will be able to get the outcome. And inside memory, like processing the data is locally available, and there is no need to have disk sick. So that is that particular, you can say, those particular operations will be more performant. So this is nothing but in memory compute, in memory processing. Then third one, like what we are having, let me say mention V1, V2, V3, V4, HDFS, Spark, and this is MapReduce. Okay. Spark, MapReduce compute engine, Spark compute engine. So we are able to differentiate, we are able to get the information uh, for the two words, like in memory compute engine. So we are able to see Spark is in memory compute engine because it is processing inside the memory, and when it is going to process inside the memory, then disk seek operations are reduced. Okay, then third one is general purpose. General purpose. So previously, once we were using Hadoop, uh, so in order to perform different operations, we are having different tools. Say I need to do the data ingestion. For data ingestion, we are having scoop and flume. Scoop and flume. Okay. Inside Hadoop, once we need to do the ingestion, we are having scoop and flume, and those that scoop and flume is having different way of coding. That means like they are having different coding mechanism, they are referring different coding mechanism, the syntaxes and all, each and everything is different into both of these two tools. Okay, if we are using data cleaning, if we want to have perform the data cleaning operation, then pig is there, Apache pig is there, and it is having pig Latin language. It is based upon Pig Latin language. So if you need to clean the data, then you need to leverage Pig, and you need to learn Pig Latin language in order to code inside the Pig. If you want to query data query, so we are having Hive in Hadoop. Okay, so Hive is having HQL, that is Hive query language. This is similar to SQL, structured query language, but this is different with respect to Pig Latin, Scoop. So this is having different way of coding. What I mean to say, all of these particular tools are having their own way of coding. Then say if we want to apply machine learning algorithm, machine learning algo, then we are having Apache Mahota, Apache Mahot. So this is a framework which has been developed by an engineer from IIT Kharagpur, and this is like in Hindi we can say Mahavata, Mahavat. So Mahavat, the person who is driving the elephant, in English say Mahota. So Mahot is there, Apache Mahot is there, which with the help of that we will be able to apply machine learning algorithm onto the data which is stored inside the HDFS. So this is also having another, you can say, way of coding. So all of these particular tools are having their own way of coding. Then say if we want to process streaming data processing, Apache Storm is there in Hadoop ecosystem. Apache Storm, and that is also having its own way of coding. So if we need to perform certain operations in Hadoop ecosystem, then we need to learn different tools. Different tools means like Scoop for the ingestion, that is fine, but all of these tools are having their own way of coding. They are not having any uniform way of coding. So this particular issue is you can say resolved, is you can say tackled by the Spark, and Spark is saying just learn one way of coding, one way of coding, and you will be able to perform all of the operations. Okay, so if you need to perform streaming data processing, then you can, with the help of single way of coding, you can do the ingestion, you can do the data cleaning, you can query the data. Okay, so all of these particular things are possible with one way of coding, one style of coding. Let me like utilize a proper word, one style of coding. So it is, you can say, it will be very difficult for a data engineer or data architect to learn all of these coding styles. Then with the help of Spark, just with one way of coding, with one style of coding, we will be able to perform all of these particular operations. And that's why Spark is called general purpose in-memory compute engine. It is general purpose because of this particular reason. Processing is happening inside the memory. Okay, instead of, you can say, the having more disk operations. So this is in-memory and compute engine, because like if we are having Spark, then we can replace MapReduce, and with Spark we can leverage different, you can say, storage layers, different resource manager. So we can say Spark is a compute engine. Okay, it is not like say Hadoop. It is not going to replace Hadoop, but it is able to replace MapReduce, because like we can club different storage layer and different resource manager in order to perform the task. And Spark is saying the same as well, just give me the storage of your choice, give me the resource manager of your choice, and I will be able to perform the task in a better way if you compare it with Hadoop. So that is why like Spark is general purpose in memory compute engine. It is, and what is the official definition for Spark? So Spark is Spark is official definition. It is open source distributed processing system used for big data loads, big data workloads. It utilizes in-memory caching, in-memory caching, and optimized query execution for fast queries against data of any size. Okay. So what we are able to see, it is open source, distributed processing system, able to handle big data workload, utilize in-memory caching, that means in-memory compute engine, and optimized query execution that we will see. So whatever we are going to perform with the help of Spark, that will be first you can say analyzed and optimized, and then operation will be performed onto that particular data. Okay, if like we are optimizing certain queries, caching, and applying distributed processing, then definitely we will be able to execute that particular query in low latency, and that is mentioned over here: query execution for fast queries against data of any size. Okay, so this is official definition, but like you can cover it with the help of these three words: general purpose in memory compute engine. Okay, now it is pretty clear, like say if with the help of Spark, just by learning one way of coding you will be able to perform 100 of the things, then why you need to learn these particular things, 100 of the things to perform 100 of the operations, huh? So there is this is the beauty of Spark, this is nothing but general purpose in memory compute engine. Just have a look and ask if you are having any doubt with respect to the definition and all, then we will cover the next topic. All of you, Gaurav, Shivam, Naresh, Rajbabu, Vandana, Rohit, Anu, Rahul, Swati, and Rahul,
No, sir,
any
no query.
confusion with respect to the definition and all? Any confusion, friends? Anyone?
No, sir, no, sir. It's okay.
Okay, 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 perfect. So let me move further. The next topic, what it will be, how data is stored in Spark. How data is stored in Spark. Now, before this, let me show you something. Spark ecosystem components. I'm going to take certain images from Google. So let me pick this particular copy. Okay, so over here, what we are able to see, we are having five layers: storage, cluster management, engine, libraries, and programming languages. Okay, so storage, we have discussed it in good detail. Like what Spark is saying, give me the storage of your choice. So it might be HDFS, Spark standalone. Like say if you are going to install Spark in single machine, then Spark is able to consume the storage of that particular machine. That is nothing but Spark standalone. If the data is there in onto the cloud, it might be Azure RDS, Azure Redshift, or S3, like wherever you are going to put the data, Spark is able to handle, Spark is able to work with that particular data. Then RDBMS, so Spark is able to work with RDBMS and NoSQL databases as well. Like this is nothing but the storage layer. We can give any storage of our choice to Spark, and Spark will be able to perform. Then second thing, what we have seen, the cluster manager. So we can club any cluster manager with Spark. It might be say Yarn, it might be Apache Mesos, it might be Spark standalone or Spark scheduler. Kubernetes is not mentioned over here, so we can have Kubernetes as well as a cluster manager for Spark. So cluster manager who is going to manage all the resources within the cluster. That is that will be the job of cluster manager. We will see once we are going through with Spark execution flow. So at that moment, these particular things will be clear. But at this point of time, you just try to feed this particular line in your mind that cluster manager is nothing but going to manage all the resources within the cluster. Then engine. So Spark Core is the processing engine over here in which is utilized in order to process the data. And then we are having certain libraries as well as Spark SQL in order to perform, in order to do the analysis uh, in SQL like queries onto top of the onto top of data which is stored in any of these particular storages, and Spark with the help of Spark Core. Then machine learning, if you want to apply machine learning algorithm, then you can have machine mlib library from Spark, and you will be able to perform that particular task. Graphics, if you are dealing with graphical data, graph related data, then you can leverage this graphics library. If you are having streaming data, then you can utilize Spark streaming library, and you will be able to handle streaming data. So previously, in order to handle say streaming data, we were having Apache Storm. Okay, for machine learning, we were having Apache Mahout. So for Spark SQL, for SQL related stuff, HQL was there, and all of those particular things were having different way of coding. But over here, just with one way of coding, we will be able to perform all of these particular operations. Then Spark is also having another benefit. Say it is not limited to one programming language. It is having support, or the person will be able to write down the code in any of these higher order language, and Spark will be able to perform process that particular data. So if you know Scala, you can write down the code for Spark. If you know R, you can write down, you can leverage the beauty of Spark. If you are having knowledge of Java, then you can utilize Spark in order to process your data. And if you know Python as well, then also you will be able to process the data. Okay, Spark itself written in Scala. So all the, you can say, new things which are coming, new features which are coming, first those particular things are coming in Scala, and then in remaining language, because this Spark itself written in Scala. So what we are able to see, we are having different components over here, and the main thing like the engine. Okay, Spark core is utilized in order to process the data. Now another thing, let me refer certain another diagram.
Ashok, the Spark act as like, I mean, it acts like an ecosystem, right?
Spark is ecosystem. Huh?
For each and every layer, we can use whatever language, whatever engine we can use, or what
Hmm,
coding
hmm,
language.
What I want to
And
share with you.
you said that actually Spark is written in Scala.
Right?
Okay.
Spark is written in
So
Scala. And
so what means
say if it is written in Scala, so whatever the new advancement, it will first come in Scala, then it is given to the another languages. Huh? Right? What else you
so
want to ask?
but
Yeah.
we have different languages, so how Spark is concatenating that?
Let me come on to that point as well. Huh? I want to show one diagram.
Because as you share that this
Hmm.
presentation, so we are having different languages and
These are APIs only. Yeah. These are APIs only. In order to, you can say, uh,
could you
say
please
I have given,
go
I
to
am
that
having four keys.
presentation?
Just a minute. It means like I'm having four keys to open a lock. Okay. Say if you are, and you can name, you can have different name to those particular keys. Huh? Say like if like I am having the key, then I can open. If you are having the key, you can open. So APIs are nothing but application programming interface. So Spark is providing four APIs in order to work with Spark. Huh? I will show you just
But
a
in
minute.
but
Hmm.
in order to work means one should have the knowledge of different languages,
No, 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 no.
different.
If you are having the knowledge of one language, then you will be able to leverage each and everything. Why I have taken the example of lock in order to, you can say if you are having a key. So say you are having the key of a particular, you can say bungalow,
I mean,
then you will be able.
my specific question just is that
Hmm.
Spark is an ecosystem, but
Mm-hmm.
still we have to differentiate between storage part means
No, 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 no,
language
no, no,
part.
no, no, no. Just try to think in this particular way. Okay.
Yeah,
So
like this. So
yes, okay.
if
So
one needs to
storage
do a
and
program,
l- let me complete. Storage, okay.
yes.
Storage, for storage, we just need to give the address like where the data is stored. Huh? For this cluster manager, we just need to refer a cluster manager in order to manage the resources from the cluster side. Huh? Then these particular programming languages are utilized in order to make the connection to Spark core. Okay, in order to make the connection with Spark core and translate the stuff in which the Spark is going to understand. Like say we are having say inside the Python, we are having merge that is utilized in order to perform the join. Okay, so over here, like we are having another function, say dot join. With the help of that, we will be able to perform the joining and all. We can utilize pandas as well over here. But certain, you can say a little bit programming methodology will be changed over here in order to interact with this particular Spark core. You are going to, with the help of these particular higher order languages, you are going to interact with Spark core. Whatever you are going to write, that will be converted into the RDD, and uh, then the execution will happen. Now let me show you one diagram. Catalyst optimizer. Actually, these particular things will come later on, but let me show you. Sorry. Okay, so just have a look. If you are writing SQL query, if you are writing data frame like you are referring, say if you are utilizing Scala, Java, R, or Python, any language, you can leverage any language. Just have a look over here as well. First, documentation and say RDD. Okay, so if you need to write down the code in Scala, then you are going to read with this particular format. With Java, you are going to have this particular format, and if you are leveraging Python, then you are going to write in this particular format. Function, like the task is same, the operation is same, but a little bit you can say method has been changed because of the programming language, the interface that I'm going to opt. So these are different languages. Now say whatever we are going to have, say I'm having a SQL query, okay, or a data frame, so that will pass with different stages, and then finally it will be converted into the RDD, and that particular RDD is nothing, will be processed onto the Spark engine, right? So whatever I'm going to write in Scala, whatever I'm going to write in R, Java, or Python, it will be directly converted into the RDD. Either I'm going to leverage RDD in order to perform a task, or utilize these higher order APIs in order to work, and then convert it into the RDD. Is it clear? Anurag?
Okay, so the major benefit for Spark is we can use different means programming languages or libraries, and it
That is one of the
it
benefit. Not major. Major is Spark is in memory compute engine. We were having Python, we were having Java. Okay, so we were able to code in these programming language. We were able to perform the operation in these programming language. Then, what is the need to club these languages to Spark? That means it is providing distributed computing framework that is not available in Python. Okay, Python is monolithic way of computing. We can have, like, we can install Python in one machine and then proceed for the processing, but that will be limited to one machine. If we need to leverage distributed computing, then we need to have Pyspark related framework, Spark related framework. So let me try to explain in a different way. Ecosystem is nothing but the combination of, like, say storage, cluster manager, and compute engine. Okay, these libraries are given, that is the internal part of, you can say, Spark. If you want to leverage, you can just import. So that is internal part of Spark. Then in order to utilize these three things, okay, we can have certain higher order APIs. With the help of that, we will be able to leverage these particular things. This is the part of, you can say, ecosystem, or you can say main components of ecosystem. On to top of this, like, we can have certain libraries as well. We are having certain higher order APIs. With the help of that, we can communicate with Spark engine. Clear?
yes.
What is the confusion in your mind?
Means it's almost clear. Means no confusion now.
Okay, so you can just think in this particular way. These are the four keys in order to open a lock of a particular bungalow. Then you will be able to utilize all the things from that bungalow. Okay, say Spark SQL. Okay, although like say if you are having Scala, then you need to change the the form of code with respect to Scala. If you are leveraging R, then you need to leverage our way of coding. Okay, so the flavor will remain same, just like you need to opt one language and you need to proceed accordingly. Just you need to learn one flavor and you will be able to perform. It is not like say you are having information of Java and you will not be able to perform certain operation. No, flavor is nothing but say one way of coding you need to have, and with one way of coding you can perform all the functions. You can do the ingestion with Python. With Spark you can write onto the disk. You can perform all you can say do the processing. You can have machine learning as well. You can utilize the graphical processing framework as well. You can process streaming data as well if you just know the Python flavor. So all of the operations will be performed. That is why like it is called general purpose. And from the developer's perspective, it is not limited. Say Python guys are able to perform operations onto the Spark. Even the Java person can perform the operation. There is no need to learn Python as well. If the person is having knowledge of R, there is no need to learn Scala, Java, or Python. He will be able to utilize the the beauty of Spark. That is one way of coding, one flavor of coding. Having knowledge, that is better, like if Scala, you know Scala or Python certain, or from the resume perspective you will be able to get more calls because certain organizations are referring Scala in order to code for Spark. Some organizations are referring Python in order to code in Spark. So from the resume perspective, it will be better, but you will be able to perform all the operation just by knowing one programming language. So that's why like we are moving with Python. That is easy to learn. However, like from the if you are having knowledge of Scala or Java, that is these particular languages are providing a little bit better latency if we compare with Python, because this Spark is running inside the JRE, Java, JVM, basically Java Virtual Machine. It is running in Java Virtual Machine, and Scala and Java, these particular programs direct are these particular you can say languages are directly running their code in JVM. Python is for plain Python, JVM is not required. So first we need to you can convert the code which is written in Python in you can say JVM acceptable format, and then it will be able to run on JVM. So a little bit you can say one step is added over here. So that's why like a little bit more latency has been added once we are coding with Python. That is another aspect, but main thing is that this Spark is providing four different APIs. Just by learning any of the language you will be able to utilize the beauty of Spark, right? So I was any doubt, anything you want to ask, you can. Meanwhile, let me show you something. I'm searching for a particular diagram. Okay, so let me copy image and paste it over here. Okay, so just have a look onto this particular diagram. Over here, this is nothing but Spark core. Okay, Spark core. And what we are able to see, RDD API. RDD is also an API from the Spark, or that is directly able to uh, get executed onto Spark core or Spark core or RDDs we can like use interchangeably. Like RDDs are directly executing onto the Spark core or Spark engine basically. On top of this, like we are having certain higher order APIs, say Scala, Java, Python, and R, which will be further converted into RDD and then will be executed onto the Spark core. So we have started this particular topic like how data is stored in Spark. That's why like we have gone through with these particular things. Say what is happening inside the world of Spark. We are having a particular ecosystem where we are having storage layer, uh, cluster manager layer, compute engine, different libraries, and programming language support from the different programming language. Okay, but like how the data is stored. So inside Spark, the data is stored in terms of RDDs. In Spark, data is stored in the form of RDDs. RDD is nothing but resilient distributed data set. Resilient distributed data set. Now, resilient distributed data set. So say once you are going to create a particular RDD, or in other words like in memory, okay, resilient distributed data set, uh, or in other words in memory, distributed data set. Okay, so resilient distributed data set or in memory distributed collection of element, in other words, distributed collection of elements. Okay, in memory distributed collection of elements. This is nothing but RDD. So once we are going to create a particular RDD, then it will be distributed among all the machines which are available, and then once we are going to perform the operation, it will be coming inside the memory and then we will be able to perform the task. Let me take an example. Say I'm having a particular file, say 1 GB file is there, and what I'm going to do, I'm going to create a RDD based upon this particular file. So same stuff like what we have seen in the world of Hadoop, like this particular file will be you can say converted into the blocks, and then blocks will be given to the different machines. So Spark is also master and slave architecture. Spark is also master and slave architecture, master and slave architecture, and we are having master node known as driver. Previously in the world of Hadoop, master was known as name node, and the slave machines are known as worker nodes. Worker nodes over here. Worker node say 1, worker node 2, worker node 3. Okay, so say we are having this 4 node cluster, one master and 3 worker nodes are there. Now I want to store a particular file that is of say size 1 GB, and I want to put it inside this particular cluster. Now master node is not going to store anything. It is going to, you can say, maintain metadata related stuff as but what will happen to the data which is there? So 1 GB file, say it will be divided into blocks, into blocks, and these particular blocks, say block 1, block 2, okay, block 3, block 4, block 5, block 6, block 7, okay, say 7 blocks are there for this particular file. So in memory distributed collection of element. Now what will happen, all of these particular machines, worker node 1, worker node 2, and worker node 3, all of these particular machines are having a cumulative, you can say, memory. Cumulative memory means, say if my cluster is having, all of these machines are having, say 120 GB, 128 GB of the RAM in each machine, GB. So what will be the total size of the memory of this particular cluster? 128 GB plus 128 GB and plus 128 GB. This will be the total memory of these three nodes. So once we are going to perform the operation, so like we are going to have executors and all, we are going to learn those particular things. uh, so we are going to create executors among these particular machine, this particular pool of memory. This is nothing but pool of memory, yeah? And say we are having 16 core onto the each machine, 16 core plus 16 core plus 16 core, so 16 core, so 48 core, 48 core in total. That is the size of the resource pool with respect to the core. And what will be this? 128, 128, 384, 384 GB, 384 GB. Okay, so I'm having 48 core CPU in this particular cluster, okay, and 384 GB, that is the memory pool. Once I'm going to process this particular, say, file 1, I'm going to take the resources, I'm going to take resources from this particular pool, and I'm going to perform. Say I am going to use, say say two executors, and say each executor is having, say, 16 GB of the memory, 16 GB plus 16 GB. Okay, so what will happen in this particular case? I am going to utilize this particular resource pool in order to process this particular data. So that means what? That means what? Like, this is nothing but in memory distributed collection of element. Once I'm going to process this particular RDD, that will come in this particular resource pool, okay, and then the operation will be performed onto top of the data. Okay, let me explain it once again. RDDs are nothing but resilient distributed data set. These are in memory collection of elements. In memory collection of elements, say whatever we are going to store in Spark, that will be moved inside the memory once we are going to perform the operation. Okay, and how it is going to utilize the resource? So this is master and slave architecture. Once we are giving certain resources to a particular machine, then all of those particular resource will club together, and then we will be having a resource pool. From that particular resource pool, we are going to provide certain resources in order to perform that particular task. So that is nothing but like in memory distribution uh, of elements. This particular file will be distributed among this particular memory, and that is nothing but a part of resource pool. Okay, so it will be available onto all of the machines based upon the size of the data, based upon the blocks that we are having in this particular data. And in that particular way only, it is it can be processed, and we will be able to get the outcome, right? So the data is stored in terms of RDDs, or RDDs are nothing but in memory distributed collection of element. It is RDD is not, you can say, limited to one machine only. Okay, it will be available onto different machines. Its blocks will be available onto the different machines, and that is the same format what we have seen in world of Hadoop. Okay, we are having a particular file, we are going to divide that particular file in terms of blocks, and then blocks will be moved onto the different machines. Okay, so that is one stuff. Now, what I want to explain, RDDs. RDDs are having two main things: transformation, transformation, and actions. These are two things, two operations that we can perform on RDD: transformations and actions. Let me give a heading: operations on RDD. Okay, resilient distributed data set. So transformation is nothing but, like, once we are going to apply an operation on an RDD, and that is going to provide me another RDD. Okay, so transformation is going to provide me another RDD. Okay, so say I was having an RDD, that is a base RDD. Okay, and I have applied certain transformation transformation 1, and then it has given me, say, RDD2, and on RDD2 I have performed another transformation 2, and it has given me third RDD3. Okay, I'm going to explain it, no need to worry. Transformation 3, then it has given me the RDD4. Okay, and then action is performed. Okay, so action that is going to execute uh, these particular RDDs. Okay, so basically what happened, once we are going to create a particular RDD, then say I'm upgrading the data. Say base RDD is reading data from disk. So I have read the data from disk, and that is nothing but base RDD, the first RDD. Like, you can think in this particular way. You have created a data frame. If you are talking in the pandas terminology, like, you are just reading something from disk and storing in a variable, so that is going to create an RDD. Okay, that is a base RDD, first RDD reading the data. Okay, now what you are doing onto this particular say base RDD dot say transformation, say you have done the filtration and it has given you RDD2. Okay, so RDD2 is like you have applied certain filtration onto this, then you apply something onto the RDD2 and RDD2 say map so map, like a particular function is there map, like mapping one to one or mapping say one input and one output so we can apply a particular function over here and we will be able to get the output we will be learning it with practically, say RDD3 is there so what we are doing onto the RDD3, you are going to apply say another, you can say function say reduce by key, reduce by key. Okay, and you got RDD4. RDD4. Now on RDD4, what you have done, you have taken an action RDD4 dot collect. Okay, so why I am going to explain I have written in this particular way. So try to focus over here in the world of Spark. Once you are going to perform, once you are going to have transformation on an RD, so it will provide you another RD. Say on RDD2, you have applied a transformation map, so it has given you another RDD, RDD3. On RDD4, you have applied reduce by key transformation and it has provided you RDD4, that is another RDD. Then at the end, you have taken an action. So we are having a list of transformation and actions. Let me show you first. So this is the list of actions and transformation. So these are the different transformations which are available in Spark, like aggregate by key, sort by key, join, co-group, Cartesian. Okay, actions like reduce, collect, count. These are the actions. So we are having certain special functions which are working as an action or transformation, and utilized to perform a specific operation. Now, what is happening once you are applying a transformation that is giving you another RD, and once you are applying action, then the actual work will start. Try to focus over here. Once we are going to apply transformation onto a particular RD, then nothing will happen inside Spark, nothing will happen, and once we are taking the action, then it will start with respect to a particular graph that is known as directed acyclic graph. That is known as directed acyclic graph. So based upon the DAG, the operations will perform, and then finally we will be able to get the answer. Let me repeat it once again. So Spark is lazy in nature. Spark is lazy in nature. Once we are going to apply transformations onto a particular data set, then nothing will be performed. Nothing will happen at that moment until and unless we are not taking the action. And once we are calling an action, then the actual work will start, and that will be started based upon the DAG, because like once we are applying certain transformation, then these entries will be mapped inside the DAG. Let me write it down. So once we are applying transformation in Spark, then nothing will happen. Nothing will happen because Spark is lazy in nature. At this time, the entries will be mapped in DAG, and once we are calling the action, the functioning will start based upon DAG. Okay, based upon DAG. That is directed a cyclic graph. So Spark is lazy in nature, friends, because until unless we are not taking an action, then nothing will happen. It is just like keep on taking the input, and it is not going to perform any operation onto top of the data. So Spark is lazy in nature. Let me move with one program, then we will have the better understanding how things are happening in Spark. So we are moving with the simple word count program. Simple word count program. So let me create certain data or take certain data from recordings. Okay, let me you can say prepare one text file over here, and we are going to have word count program. Word count program. Okay. So we are going to have certain data. Hello, how are you? Welcome to big data world. Big data is big. It is good to learn. Okay. So we are having certain content in this particular, you can say, file. Let me try to repeat something. Okay. So this particular, you can say, file is having certain data, and the data is mentioned over here. Let me copy this one, and this is nothing but the example of word count program, and with the help of you can say Pyspark, we are going to learn like how what are the different things, like how a particular RDD is being created, then what are the different, you can say, transformations what we can apply onto top of the data in order to uh, count the frequency of words. Okay, so let's proceed with word count program. Let's proceed with word count program. So the data is there. Let me open the PyCharm. So what you need to do in order to have this working environment, uh, we are having a particular uh, playlist where you can refer that particular playlist in order to build the environment, in order to set up the environment, and then you will be able to utilize, you will be able to, you can say, code in Spark, you will be able to code in Python. So you just need to go through with the playlist, and you will be able to build this particular environment for Spark that will be utilized for Spark as well. Then say Python file and Pyspark hyphen word count. Okay, so this is particular, you can say, Pyspark underscore word count program, and this will be this is the ID that we need to utilize in order to code for Pyspark. In order to move further, what I want to explain, once we are writing the code in Pyspark, so Pyspark or Spark need to have its entry point. For Spark, we need to have an entry point, and Spark context and Spark sessions are the entry points in Spark. Okay, so these two are the entry points in PySpark, but which one we need to utilize where? Once you are coding with RDD, then you need to utilize Spark context. You need to have Spark context, and once you are working with data frame, then you need to have Spark session. So these two are the entry points once you want to code for Spark. Okay. So that is fine. Like I have taken the Python as a programming API, and I am going to learn. I am going to code for Spark in the Python language. So we are going to learn, say, frequency word count program, and in order to, you can say, have this particular program, what I need to have, I can do the coding. I need to have this particular Spark context. So inside Spark, we can do the coding in ID, that is, you can say, PyCharm over here, and we can do the coding in Spark Shell as well. Spark Shell or shell scripting is also provided by Spark. So let me open command prompt, okay, and type PySpark over here. Okay, so once you are typing PySpark, then it will show something. Okay, so Python version 3.11.4, this is the Python version in this particular machine. Then we are having Spark version 3.4.0, and just try to have a look. Python version 3.11 Spark UI is available on to this particular port, and Spark context available as SC, and Spark session available as Spark. So once we are like writing the code onto the, you can say, with the help of shell scripting, then there is no need to create Spark context and Spark session. These particular things are available already available over here. Another thing, like master equal to local and star. So master, like we are running onto the master is running onto the local machine, and star is indicating like how many core I have given to this particular application, and application ID is this one. Onto the local, this is the application ID. Okay, so if like local square bracket 1, that means one core will be utilized in order to perform this particular task, and star is denoting like based upon the availability, it is going to utilize any core, any number of core. So what I have explained, so we have seen like Spark is having two main things, transformations and actions. And transformations are not, once we are applying transformation, then nothing will happen over there until unless we are not taking the action. Then we are trying to, you can say, have a word count program, and for word count program we need to have entry point. So entry point is Spark context once we are coding for coding in RDD. Then what we have seen, once we are like using Spark, you can say, once we are using shell scripting, then Spark context is available as SC, so there is no need to create Spark context over here. It is available as a SC. We just need to utilize that particular context. But once we are using IDE, then over here Spark context is not available. We need to explicitly define the Spark context. We will see. Okay, so so we are talking about a particular frequency, word frequency calculator, and the data, the file is available, the you can say this particular, you can say, data is available into hello word count. So certain space is there now. Let me try to copy and paste it over here so that no issue will be there. Let me paste the path and mention it over here, and then copy the name word count dot txt. Okay, this is the file that I'm having, and I can mention, say, base RD, yeah, base RD, and over here sc dot spark context, basically spark context, and I just need to utilize sc dot text file. This is the, you can say, uh, function that we need to utilize in order to read the text file, and then we just need to use this bracket and bracket close. Okay, so base RDD, I'm going to create an RDD, and sc.text file, this is the function that I'm going to utilize in order to read the data from this particular file. And we need to either utilize the Linux methodology in order to mention the path, or we can utilize double, you can say, backward slash, double backward slash. So let me copy and paste it onto the terminal. Mhm. Okay, so type of base RD, base RD, and I want to print print type of base RD. Okay, so what it is giving me, Pyspark.rdd. Okay, so this is a particular RD that I have created based upon the reading of the data from this particular file. Now let me try to utilize, let me try to check what is there in base RDD, base RDD.collect. Okay, and it will provide me, hello, how are you, welcome to big data world, big data is big. So we are able to read the content what is available in that particular file, and with the help of this, what we have seen, I have created an RDD, and collect is an action. So if I have created this particular RDD, nothing has happened. It has not even read the data from that particular file, because once you are going to create an RDD, okay, nothing will happen. Once you are going to once you are going to apply transformation, then nothing will happen. That is nothing, because that is happening because Spark is lazy in nature. Let me try to show you. So this is the RDD that I'm having. Now what I want to do, in order to, you can say, I'm having this particular content. Let me copy from here. So I'm having this particular content. Let me paste over here. Huh. So it is looking like this. For the better visualization, I have mentioned in this particular way. Now this is the content of base RDD. Okay. Now perform I want to perform the frequency calculation, word frequency calculation. So what I need to do, first I need to split this particular, you can say, data based upon the space, so that I will be having separate words. Like I want to separate each and every word. And once I'm going, let me tell you the methodology. So if I'm having hello, how are you, these are the three words. So I'm going to create three words. I'm going to split it based upon the space. Once I'm going to split based upon the space, then the data will be visible in this particular way. Say it will be visible, it will be available in this particular way. So it is the string one. So hello, how. So once I'm going to split, it will be visible in this particular form. And then I'm going to apply one with each and every word, same what we have done in Hadoop. Okay, so this is the logic basically. So I am going to split the entire content, entire data based upon space. Once it is splitted based upon space, then what I'm going to do, I'm going to fix one, okay, with each and every word. That will be the next step. Okay, okay, in this particular way, I'm going to fix one with each and every word. Okay, then once I have like done this, then what I'm going to do, this is nothing but key and value pair, key and value pair. So say I'm having the data like this big one. Okay, I'm having the data with this key and value pair. Okay, so what I'm going to do, I'm going to keep the key and apply a sum function onto the value. 1 plus 1. I'm going to take say two values, then apply the sum, then it will be say 2, and then I'm going to like add it with the third one, then fourth one, then fifth one, and sixth one. And at the end I will be able to get say big 6. 1 2 3 4 5 6. So big 6. And that is the methodology I'm going to apply in order to calculate the frequency of each and every word. Okay, so sorting and shuffling will happen before, you can say, this particular uh, key and value mapping, like we are going to keep the key and apply the sum onto the values. Okay, so this is the methodology. Let me try to explain with the code. Now we are having this particular data, and I'm going to apply splitting based upon space. So base RDD dot flat map. Flat map is a transformation which is going to, you can say, flat map is a transformation. Once I'm going to apply flat map, it is going to take say one input and provide multiple output. It is going to take one input. This is one input what I'm giving, and it is going to provide multiple output. Once you need to have one input and multiple output, then flat map is the transformation that you need to apply. Okay, you can see the description over here as well, like what flat map is doing. Flat map similar to map, but input can be mapped 0 to more output values, 0 to more output values, or you can say 1 to more output values. So one input and multiple output, so flat map will be utilized. Now lambda function I'm going to utilize a lambda. If I'm giving x as an input, so it will provide me x dot split, x dot split, and split based upon what? Based upon space. Okay, so this is nothing but x. Okay, I'm giving this particular x, and what I'm doing, I'm splitting x based upon space, and I'm going to store it in flatted RDD. Okay, so this is flatted RDD that I'm having. Let me try to copy this code and paste it over here. Okay, and nothing has happened. Nothing has happened at this moment. Okay, because this is a transformation, and once we are applying transformation, then nothing will happen. But we want to see what has happened once we have applied this particular transformation. Then what we need to do, we need to apply an action. So I just want to apply an action onto this particular RDD, say flatted RDD dot collect. That is an action, collect is an action, and just have a look what it has done to the data that we are having. So hello, how are you? Just have a look, and this is what we want. This is what we want. This is what we want. Like each and every word has been splitted based upon the space. Now we are having different words. Hello, how are you? Previously it was how are you? Okay, like we were having one component. Now we are having three components, and it is possible. It has been possible because of this split what we have used over here. Okay, now the another logic. What I want to map one with each and every word. Okay, so once you are having, let me write it down. Flat map, flat map is giving, flat map transformation is giving or is taking one input and providing multiple output. Okay, flat map is taking one input and providing multiple output. That is fine. And now map transformation I'm going to apply in order to map one. Map transformation is taking one input and providing one output. So if I'm going to give hello, so it is going to provide me hello one. This is the, you can say, single output only. If I'm giving how, so it is going to provide me how one. Okay, so single output. Just onto the flatted RD, I'm going to do what? I'm going to apply map transformation dot map, and I'm going to use lambda expression. And if I'm going to give x, okay, and I want to get x comma 1, okay, I want to get 1 with x, that is fine. Let me, and I can store it in mapped RDD. Okay, let me copy and paste it over there. Okay, so This is the transformation what we have applied over here. So nothing has happened, but we want to see what has happened onto the data, because like we are in learning phase, so we just want to check what has happened onto this particular data. So I want to take an action, so action has been taken, and now just have a look. So hello one, how one, r1, u1, and that is the same stuff what we want. Hello one, how one, r1, u1, welcome one, to one. So this is possible because of this particular transformation. Now what I need to do, whatever I'm having over here, I need to short it, and I just need to, you can say, have, I need to fix the key and apply sum onto the values, then I will be able to calculate the frequency of each and every word. So we are having a particular transformation, reduced by key. Okay, let me show you. Onto the mapped RDD, onto the mapped RDD, I'm going to apply another transformation, that is reduced by key. And over here, it is going to take two inputs at a moment, lambda x comma y, and it is going to provide x plus y. Okay, things are looking fine. Let me pass it in a variable or RDD, say reduced RDD, and let me try to execute this. Okay, so, and this is an RDD, and nothing has happened at this moment until unless we are not taking an action. So on to say reduced RDD dot collect, then I will be able to get the final output. Okay, so just have a look how one, r1, u1, comma, inverted comma, one, welcome one, 2 7 is there, big 9 is there, world 1 is there, it 6 is there, good 6 is there, learn 6 is there, hello 1 is there. Let me try to copy this and paste it over here. And with the help of this particular, you can say, uh, transformation, we are able to get the frequency of each and every word. Okay, now you need to think over here, like with respect to the flat map transformation, like taking x and splitting on x, that is fine. We are able to get the outcome. Then lambda is also like taking x as an input and providing x comma 1 as an output, that is also fine. But over here we are taking two, you can say, variables, x comma y. But how it is possible, x comma y, so how it is taking two variables? So over here, say once the data is shorted, it will look like this, say big one, say first is say big one, and then say world one. The data is there in this particular format, world one, okay, and say welcome one. Okay, so data is there after shorting, say it has been alphabetically shorted, and we are having this particular data now. Sorry, what reduce by key is doing, it is going to take two variables x and y, and then apply the function that we are, apply the operator that we have mentioned over here, so plus. So what is happening, it is going to take two rows at a moment, and then it is going to fix the key, say big, and apply the function or operator what is available, 1 plus 1. So this is x and this is y. Okay, this is x and this is y. So based upon this, like, we will be able to get big 2. Now we are having this big one, so it is going to check, like, do we have another big? So yes, we are having another big as well, big one. So at this moment, this is x and this is y, so the function, the operator will be applied, that is x plus y. So 2 plus 1, then it will give big 3. Okay, and then it is going to check like do we have another rows. So yes, we are having another rows, then that big one will be taken. At this moment this is X and this is Y. Okay, so big 4 will be there, big 4. So in this particular way, the execution will keep on happening, and finally I will be able to get the sum of the frequency of that particular word. So this is how like the reduce by key transformation is working onto the data that we are having. Okay, so this is the simple word count program. Just have a look and ask if you are having any doubt. Just have a look. Shivam, Naresh, Rajbabu, Rohit, Anu, Swati, Rahul. I think Anurag. Any doubt?
Sir, while applying the reduce key by key, it's only adding the values. Means key is the same what it's taking.
So what else you can apply?
No, means I means the too big two key. Not like that. Only the values is only adding the values in a word count number.
Mm-hmm.
My question is, sir, it's only adding the values, not key. Key is the same. It's adding not
Mm-hmm.
key. It's only adding the values that's
Mm-hmm.
attached with them.
Mm-hmm. So that is the normal functionality of reduce by key.
Yes,
Okay,
sir.
it is working onto the like reduce by key is working with respect to keys. Like say it is going to fix the key and do the operation, or reducing key. Say we are having 6 keys with the same description. Okay, so it is going to reduce it once and providing apply the logic that we are going to mention over there, and based upon the logic, say over here we have applied plus. Okay, so reduce by key, what the reduce by key is doing, it is going to reduce these particular keys based upon the logic that you have mentioned over here. Reduce by key is taking two inputs. Okay, and based upon the available keys it is going to work on those particular keys and provide me the outcome. If you are going to, you can say, uh, apply, say, a multiplication operator, then multiplication will happen over here. If you are going to apply, say, minus, so minus will happen onto those particular keys, huh? So depends on you which operator you are going to utilize, but the reduce by key transformation is taking two inputs and providing outcome accordingly.
Sir, how it measure that this one is key and this one is values? How it measure that one?
So over here, like this one, the first one is key, and if you are going to change it, okay, we will in the next session we will be going to change the you can say position. Say this one we are going to place at first, and then big we are going to place at second. So position we are going to change, and then we are going to work, apply certain transformations over there. At that moment, like say we need to apply the function onto the key, not onto the value. Okay, so reduce by key is working like taking the key and working onto the values. So we can replace this particular position, and then we will be able to see that things will happen, right? We are going to change the position of big and this one, and then we are going to apply. You will see, no need to worry. Okay,
Okay, sir.
that like we are having the decision power. So over here big is like first one is the key and second one is the value. Okay, this is the format. This is the format. But if we want to make one as a key and big as a value, then that is also possible. We just need to interchange these particular values, and then functioning will happen in that particular way.
Okay.
Right?
Right, sir.
Okay, we are having the decision power in that particular case. No?
Right, sir.
Mm-hmm.
So on top of it, let me have one more question. Like, how we will deciding that okay, now flat map has to be there, map is has to be there, reduced by has to be there. Like just by seeing the problem statement, how we will get like how we will get the output from this problem statement. Means what
Yes,
has to be there in your mind so that we can just have this calculation that okay in this place flat map will be working, reduce by will be working, how that will be coming.
so, so let me ask a simple question. Like uh, if you are having three balls, okay, and or you can say if you are having 10 balls and you want to distribute it in two-person, so how you are going to distribute it? You are going to divide it by two, and then you will be having you can say like five balls will be given to two persons. Huh? So you must understand the functionality of each and every transformations, how the transformations are working, how the transformations are providing me the outcome. Then you need to understand the problem, what is being asked with respect to the problem statement, which transformation I am able to map onto that particular case, right? Then you will be able to you will able to say that yes, this is the transformation and that I can apply. Right? Practice is the key over there. Like blindly you can't say like without going through with the problem, you can't say like I can utilize flat map or I can utilize reduce by key. You just need to understand the problem, right?
Yeah, sure, sir. So one more question,
Okay.
like here you have just applied the split function onto the complete file.
Mm-hmm.
Sorry. If I just want to apply the split function into some part of it, how I can go for it? Like if I'm having a RDD, which is in a pipe, pipe separated,
So,
and then I
so,
just
so
have to go for splitting one part of that pipe separated thing. How I can go
okay.
for doing it?
So, so over here, like the data is given in this particular way. Uh, Let me open this. So data is given in this particular format, like we can utilize space as a splitter over here. Now, if you are having multiple splitters in your file, then you need to like say then you need to utilize multiple splitters over there. In your code, you need to apply multiple flat map. That is one thing. So, like if the data is unstructured, if the data is structured there, then you can take one, you can say, column by mentioning the index of that particular column, and you can apply the desired splitter over there. You will see. So that is the second aspect in order to apply splitter. Then say if data is structured and multiple, you can say, splitters are there, like dollar is there, space is there, tab is there, then you need to refer rejects. Okay, so rejects are there. You just need to find out the logic, what you can get. Like say you are having you need to find out the pattern. So rejects are utilized in order to find out the pattern, then you can have that particular rejects in order to split the data. So three methodology you need to have in order to split that particular data: structured and unstructured, that is the first one. And if structured is there, then you need to just refer the indexing part, right?
Okay, sir. So one more thing, like we have in Excel, right? The first row has to be your what you say, column names, and
Schema.
then in the next row from the next row you will be having data. Same you are having
Mm-hmm.
in your RDDs, like your RDD is having your column names.
RDDs are not having
And
schema. These are
okay,
schema-less objects.
okay,
RDDs are not
okay,
having
sir.
schema.
Okay, sir. Let me just share you the question. Let after this class, then we can go for discussion over there.
Mhm. So if
Yeah.
like you need to proceed with schema related stuff, then you need to refer data frames. RDD will not be suitable in that particular case.
Okay, means if you are going for RDDs, then there is no point of having any schema related thing in it.
Yes, yes, these are schema-less objects. Let me explain one more thing. So, so this is the word count program. So in Pyspark or Spark, we can do the coding in four different ways. Spark. Number one is say RDD. These are schema-less objects. Schema-less distributed collection of elements. Distributed collection of elements. Functionality is limited in case of RTDs. Even like nowadays, no one is referring, no one is coding in RTDs. Before Spark 1.3, these RTDs were available. Spark 1.3. Okay, after Spark 1.3, then data frame came into the picture. Now, what we have done over here, schema was imposed on RDDs. Then it becomes a data frame. Now, at this moment, like if you need to read data from say CSV file, JSON file, those are having a valid schema. Okay, you can infer the schema as well over here. You can have your own schema. If the data incoming data set is not having schema, then just by discussing with the SME, you can write the schema, you can create the customized schema for that particular data set, and that is possible with the help of data frame. Then we are having structure streaming. Structure streaming. So once you are applying, you can say once you are analyzing RDDs, once you are leveraging RDDs in order to process streaming data. So that is structure streaming. And Spark streaming and Spark structure streaming. So once RDDs with schema, that is nothing but data frame. Okay, to process or analyzing streaming data. Okay, so these are the four ways with the help of that we will be able to process our data. RDDs, batch processing, data frame, that is also batch processing. This is streaming processing. Okay, streaming processing will happen over here. So batch processing, from the batch processing perspective, RDD and data frame. RDD, no schema will be there, schema less distributed collection of elements, and data frames, like we are having a schema is imposed onto the data, RDDs, and then we are having certain other benefits. We will be having, you can say, detailed discussion with respect to differences between RDD and data frame. But like as you have asked, then ask, then like I have mentioned these particular things. So if you are having certain stuff where schema is mandatory, where you need to apply the functions with respect to schema or do the calculation with respect to schema, or you need to have the outcome with schema, then you need to refer data frame. Then RDDs will not work over there. RDDs, with the help of RDDs, definitely we can do certain set of operations what we are going in data frames, but data frames are more advanced with respect to RDDs. These data frames are having certain optimization related stuff as well, like the catalyst optimizer what we have seen, that is available in data frames only. Okay, so once we are coding with data frame, then we can take that benefit of catalyst optimizer or tungsten engine. Okay, right, Swati? Is it fine?
Yes, sir. Thank you, sir.
Okay, okay, perfect. So what we have seen, friends, we have gone through with a simple program, that is the word frequency calculator. Let me write down the program lines. Okay, this is in order to read the data. Then a flat map for splitting the data based upon the space. Then mapping one with each and every word. So map transformation is there. And finally, we are having reduce by key. That is the transformation which is taking the keys, fixing the keys, and apply the operator what we have mentioned over here onto the values. Okay, so these are the four lines in order to calculate the frequency, and all of these are nothing but transformation. Till this particular step, nothing has happened in Spark. It has not read the data, it has not splitted it, it has not, you can say, applied mapping, or it has not applied the reduce by key. Okay, until and unless we are not applying an action over here, nothing will happen onto the code. And these particular entries are mapped inside the DAG, what we have seen. So DAG, once we are taking an action, once we are calling an action over here, say RDD this dot collect. Okay, so once we are applying this particular action, then the operations will happen onto this particular data and we will be able to get the outcome. So actions are mandatory in order to perform an operation in the world of Spark. And this particular thing is known as lazy evolution. Okay, Spark is lazy in nature. Whatever we are going to perform with the help of Spark, it is going to evaluate it lazily, and that is giving certain benefits as well. So let me copy this particular code and paste it inside the IDE. Okay, so IDE. Now what we are able to see SC. Okay, and it is showing unresolved reference SC, because if you need to work with Spark, you need to have the entry point. We are working with RDD, and for RDD, we need to have an entry point that is Spark context. So this particular PyCharm ID is not having that particular information. So I need to explicitly define the Spark context so that the entry point will be mapped over here and I will be able to perform the operations within the Spark. So from Pyspark import Spark context, Spark context, that is fine, and sc equal to Spark context. Okay, so let me try to mention in this particular way. Okay, so from Pyspark, I have imported the Spark context and S equal to Spark context. And now let me try to perform this particular operation. Let me try to execute. Okay, okay, current file. Okay, So Spark context, missing argument, potential argument. Okay, I can mention say local. I can mention local over here, and I can give a name, say word count program. So this is local is nothing but what we have seen over here. Like this Spark is running, master is running on local. So same local is utilized over here. We can mention the core as well over here, and word count is nothing but the application name. App ID local hyphen this. So we have mentioned an app ID word count. Let me try to execute this. Okay, so execution has been done, and we are not able to see anything. We are not able to see anything over here because, like, action has not taken over here until and unless we are not, you can say, taking an action. Nothing will be performed, and like it has not read this particular data set as well. It has not applied the flat map and like map transformation, so nothing has been applied. So let me try to apply this action, like collect is an action in the world of Spark, and let me try to print the output, and then reduce the RDD that collect. Let me try to execute it. So execution has been started. Just try to focus. uh, Spark UI could not bind on port 4040, attempted to 4041. We will be like going through with this as well, like how to see the Spark UI and all. And just have a look, hello one and big 9 data 5. This is what, like, the same output what we have seen over here. But in this particular case, we have gone through with IDE, and over here we have gone through with the Spark, you can say scripting. We have gone through with the terminal. So the same thing, but what is the difference? Inside the PyCharm IDE, friends, we have explicitly defined the Spark context, and Spark context is the mandatory stuff. It is the interview question as well, like why we need to have Spark context, and the answer what it will be, like this is the entry point to the Spark cluster. Okay, so we have explicitly defined the Spark context over here, and then like the same code is being utilized over here, and we are able to get the same output. Okay, so this is the word count program that we have seen. Now, what are the different ways to create RDD? What are different ways to create an RDD? Okay, before moving further, what I can suggest, try to run this code by yourself and provide your confirmation, because that is the mandatory stuff. Like until unless you are not running the code, then that will not make any sense. Try to run this particular code and provide your confirmation that you are able to run this particular code or not. Try to run this code and provide your confirmation, and try to run it onto the terminal, command prompt, and on PyCharm as well.
Sir, please share the text file.
Raj Babu, your voice is not clear.
So please share the text file. which you have
Text file
used.
you can create, like just mention certain lines. There is no
Okay.
need to, you can say, be dependent onto a particular file. Try to create a file name hello world or whatever and mention certain content over there. Okay. So try to create a file, apply this particular code and provide your confirmation.